Welcome everyone. In this video, we are going to derive two formulas. One for sine of alpha over 2 and another for cosine of alpha over 2. So the first question is, what is sine of alpha over 2? And this is sometimes called the half angle formula for sine. And today we are going to derive it. So let's get started. I want to start with the cosine sum formula, which is as follows. Cosine of alpha plus beta. And this is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. But don't take my word for it. You can access this derivation from the cards right now, also from the descriptions part. This is a classic formula and you can access its derivation. So with this given, what I want to do is, for alpha and for beta, I will substitute alpha over 2. So for each angle, I substitute alpha over 2. And if I do that, I will have cosine of alpha over 2 plus alpha over 2 is equal to. We have cosine of alpha over 2 times cosine of alpha over 2, which is just cosine squared of alpha over 2. Minus, we have sine of alpha over 2 times sine of alpha over 2, which will just give us sine squared of alpha over 2. Now, I'm just going to sum this parentheses. It is going to give us alpha. So let's just write that. We have cosine of, and let's switch colors. Why not? Alpha. Cosine of alpha on the left side. On the right, we have cosine squared of alpha over 2 minus sine squared of alpha over 2. This is cool, but I will write this in a form that will make our calculations much simpler, much easier. And to do that, I will use the fact that cosine squared of theta plus sine squared of theta is equal to 1 for any angle. And I derived this formula in a previous video. I will attach that to the cards and to the descriptions part. Okay, you can access that as well. So we have this. This is sometimes called the Pythagorean trig identity. Okay, so if we have this, then for let's say sine squared of alpha over 2, I can, you know what, actually, let's substitute for cosine first, because I said we would find sine initially. It doesn't matter, but let's do that. So if we substitute for cosine squared of alpha over 2, what is it going to be? So let's solve this blue one for cosine squared of theta. It is equal to, cosine squared of theta is equal to 1 over 2 sine squared of theta. Cool. Now I can substitute this for our formula. And when I do that, I will have, instead of cosine squared of alpha over 2, I am writing 1 minus sine squared of, don't write theta because our theta is alpha over 2 in this case. Then minus sine squared of alpha over 2. And of course, if we combine the last two terms, we get 1 minus 2 sine squared of alpha over 2. And look at this. We are able to solve for alpha over 2. For sine of alpha over 2. And let's do that. So if we add 2 sine squared of alpha over 2 to both sides and subtract cosine of alpha, we will get 2 sine squared alpha over 2 is equal to 1 minus cosine of alpha. And if I divide both sides by 2, this will be divided by 2, and I will erase this factor of 2. Now all I need to do is taking the square root. So let's do that. If we have sine of alpha over 2, we will have 1 minus cosine of alpha divided by 2 under the square root. And you might be saying, oh, we are done. No, we are not done. We forgot a very important idea. We forgot the plus or minus. This is incredibly important. When you take the square root of a square, you need to put plus or minus. Otherwise, it is incomplete. So don't forget the plus or minus. And this is now the formula for half angle for sine. Now let's do a similar thing for cosine of alpha over 2. And let's do that on the new page. So now we're asking the question, what is cosine of alpha over 2? Now I will start this derivation from a previous step of the last derivation. I will start it from this point. At that point, we have on the left cosine of alpha is equal to. On the right, now I will substitute for sine squared of alpha over 2. Okay? And let's see what I want to substitute for it. Let's do that in green. So I am going to manipulate this blue part in green this time. So if I solve for sine squared of theta, I get 1 minus, is it minus? Yeah, it is minus. 1 minus cosine squared of theta. Now I am going to substitute this in our equation. And let's do that on the new page. So first we have cosine squared of alpha over 2 minus, we had sine squared of alpha over 2. But now we are going to substitute for it. What are we going to substitute? We are going to substitute 1 minus cosine squared of alpha over 2. So we have 1 minus cosine squared of alpha over 2. Which is, if we distribute the parentheses and add up the terms, 2 cosine squared of alpha over 2 minus 1. And again, we see that we are able to solve for cosine of alpha over 2. And let's do that. We add 1 to both sides to get 2 cosine squared of alpha over 2 is equal to, I said squared alpha cosine sine a lot in this video. But anyways, this is what we need to do to carry out this derivation. So we have 1 plus cosine of alpha. If I divide both sides by 2, I need to erase this factor. And now I can take the square root of both sides. When I take the square root of the left, I will have this. And on the right, we have 1 plus cosine of alpha divided by 2 under the square root. And don't forget the plus or minus. And this is the other formula. This is the half angle formula for cosine. I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.